Yeah, that is correct. Yeah. I'm recording, people. Keep on your best hat. All right, we're going to add in LD50 to the bottom of Part F under pest control methods. One, because we're starting to talk about harmful chemicals, and it's important to know like how the government regulates what chemicals you can be exposed to, and like how much of a chemical you can be exposed to. What are you laughing about? Seventh period. I should be tired, not even talking. Unable to pay attention at this point in the day. All right, so LD50. LD50 stands for, it's on 474, stands for lethal dose 50. That means the dosage that will kill half the population. So if you were testing a chemical, or it could be a pharmaceutical, some kind of drug, you first have to test that on mice and rats and see how it affects them. And then you have to test it on another animal, usually like rabbits or something like that, something easy that grows fast. And then you can go to human trials. So LD50 is one way to determine like the dose you can give to people, because you don't want to give people so much of something that they die, right? So basically what you're going to do is take that amount. You can use that amount that's like harmful to mice, and then you basically kind of scale it down until you get to a lesser amount, and then you can apply that to humans depending on how big they are. So bigger you are, the higher the dosage you can take, that kind of thing. And another thing that you may see, but I doubt it, is ED50. It's at the bottom of 474. That's effective dose. That might mean like if all you guys are exposed to radiation and half of you started throwing up and got explosive diarrhea or something like that, the effective dose would be the amount that it affects half of you. We got a new student in right now. She came in late. And
right here, Sarah.
She's back.
I don't want to touch
First day I
that.
come back.
Don't let me touch that.
She's back. Yeah.
Hey, remind me when we're done with notes today, y'all have to check your plants and water them and stuff. For those of you at home doing the salinization lab like you should be doing, hopefully it's going well. Good to see you back, Susie. I saw you singing this morning. I thought, hopefully she gets back today in class. Something important. I saw you out walking your dog in Braylon Village Sunday afternoon about 1 o'clock. Just bebopping down the road.
That was so specific. All right. Do I need to do a sterilization?
Little brown dog. What?
Do I need to do that sterilization lab?
Yeah, you were supposed to start it last Friday like everybody else.
Yeah, but like I was thinking since I came back today.
I guess you can start it today, sure.
No, I started it, but I didn't know how far I needed to get since I came back today.
So you had some seeds and stuff?
Yeah.
Oh, well then you're fine. Just keep doing what you're doing at home. We're really just looking for germination on the salinization lab and seeing how the plant's like initial growth is. Hopefully by Friday, which y'all won't be in here Friday, hopefully by Thursday, most of your seeds will have germinated. You will have good data so that you can kind of compare like how did the different salt levels affect the seeds and their growth. And then you can get enough data where you can graph that and come draw some conclusions from that. What in God's name are you doing? All right, LD50. So at the top of the page, what is the LD50 in that graph? What is the lethal dose that kills 50%? This is some hypothetical data, but we'll pretend.
It's about.
We're at the top of 474. For you three people at home watching
It's
this,
about like 5.7.
5.5, good. Close enough. It's not, it doesn't have to be exact. So about 5.5. Here, another term you need to be familiar with is threshold, Antonice. Threshold is what? When you use the term threshold, threshold is when you cross a barrier. You know, you hear about somebody like they got married and the husband carries his wife across the threshold, and we're not getting any further than that. But it's crossing a barrier into some other realm, so to speak. So where do you think the threshold would be on this chart? At what dosage? No, where did it start affecting the organisms?
At 3.
Yeah, about 3. So 3 would be our threshold when it starts to impact. So you've crossed a barrier and it starts to increase. God bless America. So knock at the door. Make sure they're not terrorists.
Also, it's like. Abigail.
I'm trying to see what we missed today. Or what I missed today.
We did that FRQ right there.
Oh.
One on the left. Left. Your other left. There you go.
Okay, thank you.
Hey, I want you to do that. Take about 20 minutes. Take about 10 minutes and do it. And whatever you can't figure out, use your book. Try about 10 or 15, 10, 5 or 10 more minutes. And then after that, if you'll Google, it's 2015 number 1, I think. If you'll Google scoring guide, AP Bio FRQ scoring guide, then go through and self-grade that.
Okay.
All right, have a good day off. That was a little sassy door slam. Blah, blah, blah. All right, so LD50. Let's look on page 475. Who wants to read? Good, Reagan. Second paragraph on the right side.
Starting with what?
It says 4, but okay. 475, right side, second paragraph.
For humans, however, the regulatory agencies are much more conservative in setting concentrations. As mentioned earlier, dose-response tests cannot be conducted on humans. Therefore, scientists conduct dose-response experiments on rats and mice and then extrapolate the results to humans.
All right, what does extrapolate mean? Extrapolate. It's a big word. You should know it. You're almost adults. Don't worry, there's a lot of adults that don't know it. Extrapolate means extend the results to. So if you had a 1 pound rat, Simona, and you gave it a certain amount, you found out your 1 pound rats, you were giving them arsenic and trying to figure out their LD50. And let's say for that 1 pound rat, the LD50 is like 5 grams. So 5 grams of arsenic, boom, kills half of them, okay? The other half survive. They're probably all throwing up, about to die, but they survive. So, a 100 pound human, what would be their LD50 if you extrapolated those results to them? A 1 pound rat, it was 5 grams.
500.
And so for a 100 pound human, it would be 500 grams. Good. What?
Where are we at the notes?
Don't take 500 grams of arsenic. You'll die before you choke it down. Don't and avoid arsenic at all costs. And to be honest with you, these rat traps where they sell rat poison, a lot of those contain arsenic. It's just like cause them to bleed out. It's not a very nice way to go. I feel like if I was a rat, I just want something to snap my head off. I don't want to be stuck on a sticky trap and starve to death.
And pull yourself apart.
Pull yourself apart. I don't want to be, I don't want to bleed out every orifice and die from arsenic. You may, yes. You don't even have to ask.
I'm just making sure you're not like, whoa.
Do you have any tissue?
Like,
Hold on a second.
huh?
I gotta get some tissue. All right, so keep going. You, Reagan? Yeah.
Okay. The LD50 or ED50 values are then divided by 10 to determine a safe concentration for rats and mice. This value is divided by 10, again, to reflect that rats and mice may be less sensitive to a chemical than humans. Finally, this value is often divided by 10 again to ensure an extra level of caution. In short, the LD50 and ED50 values are obtained from rats and mice are divided by 1,000 to set the safe values for humans. Do the math, estimating LD50 values and safe exposures shows how you make this calculation. Good morning, your math.
I'm like,
You're gonna blow it through the mask? Just go out in the hall like a normal person. Cannot blow your nose through a mask, people at home. Remember this. Okay, so good job. So on the LD50, so for humans, for it to be considered safe for humans, it's got to be less. How much less than the LD50 for rats or mice or whatever? You got to divide it by 1,000. God bless America. Did y'all not listen to her when she was talking? Obviously not. All right, turn
Brendan
it.
said 10 and she's the one who read it.
You said 10?
Said multiple times.
Yeah, and then the last, in short, the LD50, ED50 are divided by 1,000 to set safe values for humans. Did you not read that far?
I did.
All right, turn over to part N in your notes and turn to page 299 in your book. Unbreak my heart, say you love me again. Thanks, Tony Braxton. Thanks. $2.99. All right, $2.99. We've already discussed briefly integrated pest management yesterday. Let's dive a little bit deeper. Now, I don't know what person at the College Board is putting all this stuff in order, but I don't like it. So that's why we just talked about integrated pest management yesterday. Let's get a little bit deeper. So that's why we're skipping over to part N. Integrated pest management. The primary goal of integrated pest management is to what?
Minimize pesticide input.
Genius. So you are trying to minimize your pesticide usage. Combination of methods to reduce pesticide and minimize the impact on the environment. So we want to be able to reduce the pests. We want to be able to grow food, but we want to limit how much pesticides we have to use. Includes biological. Biological methods of pest control would include what? Ladybugs. The wasp on page 299. It could be plants like marigolds or I don't know, well, any other kind of plants, citronella, lemongrass, things that deter pests that could grow, be in your garden. Physical. Physical means you create a physical barrier for those pests. So if you had a lot of insects and you had a small garden, like a small raised bed, you could take some netting. They sell like really fine netting, and you could lay it over those plants. A lot of people do that. Or you could just throw gallons of Seven Dust over it and do it that way. I don't know. Which one would you rather ingest? You can pick it up. Just use your foot. There you go. There you go. You got it. All right. So that's physical control, pest control, and limited chemical input. So limiting the amount of chemicals or chemical pesticides, what it's talking about, into your crops. Intercropping, page 296. Let's back this thing up. There we go. Intercropping on 296 says 2 or more crop species are planted in the same field at the same time to promote a synergistic interaction. Synergy means what?
Working together.
Work together. Loving you forever. All right, good. Example, corn and beans can often be planted together in a synergistic intercropping. Corn needs lots of what?
Water.
Soil.
Nitrogen, good. And beans have these bacteria that grow in their roots that fix what?
Nitrogen.
Nitrogen. You're a genius. Remember those nitrogen fixing bacteria we talked about? So when you plant the beans and corn side by side, the beans provide nitrogen. The corn provides a place, especially if you got pole beans, it provides a place for the beans to grow up, and it's a win-win, okay? Now, you probably studied in history class that the Native Americans used to plant 3 crops together. What were they? Y'all heard of it? Were they planting them?
Corn, bean, rice, right?
The 3, it's called the 3 sisters. What are the 3 sisters, Antonice?
Isn't it maize?
Okay, corn,
I was gonna say maize. It's
maize,
maize. Yeah.
Maize.
corn.
Amazing.
That's the first thing.
What else?
You know what's wrong?
Beans and nope.
Rice.
No.
That's a crop.
You're not gonna grow rice next to wheat or beans, that's for sure.
back up.
That was like the first
I
one.
don't know.
That's what I thought of though.
Squash, good. So all three of those you grow together.
Gosh.
We talked about the benefits of corn. Did y'all not learn about this in history class?
It was like the first thing we learned.
First thing you learned?
Yes, the
What was
very
that last
first.
one?
Yeah.
Squash.
I swear it wasn't
What is
squash.
Oh, squash. I was like sludge. I was like,
What
what?
is
Sludge. I don't know. It was like
Squash.
I was confused.
squash?
Squash. All right. So, what benefit did the squash provide to the other two?
It gives off nitrogen.
No, that's not true. No. So, squash goes on the ground and has really big leaves. You ever seen squash leaves? You need to grow some more stuff together. So when the squash starts growing, those big leaves have to cover the ground, which helps the plants with what?
Drying down.
Retain moisture, and it also prevents growth of weeds. Good. So the squash benefits helps in that way. And they all three have different like depth of root structures. So they're all kind of it helps to reduce competition between the three, and it also helps to loosen up the soil, and they just really work really well together. So that's working with the plants. Synergy, that's what we want. Yeah. All right, crop rotation. Why do most farmers in the United States, they're going to crop rotate. They're going to plant corn one year, soybeans the next. I'm talking about big farming operations. Corn, then soybeans. Why do they not just plant the same thing over and over?
Because it depletes the soil.
Depletes the soil of nutrients, and how's it going to affect pests? If you plant the same thing every year, they're going to keep coming back. They're little baby. They're going to make some babies. They're going to come back the next year. They're going to make some more babies, and you're just providing a beautiful buffet every year. When if you switch it up, then they're like, oh, I wanted some corn, and now I got soybeans. What am I supposed to eat? So it helps in reducing your pest problems as well as limiting the outtake of nutrients, specific nutrients. Natural predators. We already talked about ladybugs, wasp. I'm sure there's a bunch of others. I don't know what they are. Integrated pest management reduces the impact of pesticide on wildlife, water, and humans. Now, if you're growing a big field of corn, Damar, and you go through there, you plant your Roundup Ready corn, you spray your insecticide over the field because you have some worms come in and try to get in your corn. What happens if you have a big rain right after that?
Then it's gonna wash away.
Okay, so it's going to wash into the stream, nearby stream or creek or river. And what's it going to do to the insects in there?
It's gonna make are they gonna wash away too? Or are they
If you spray insecticide on your field and and that insecticide runs off, washes into the stream or river next to you, what's going to happen to the insects in the stream or river? They die too. Good, because a lot of these insecticides, herbicides, they're killing a lot of different types of plants or insects or rodents or whatever, and so they have an impact through the ecosystem. If you, Jacayla, are planting your corn and you spray you got some Roundup Ready corn and you spray all your Roundup and it rains that day, kind of like today, and what's going to happen to those plants in the water? They're going to die. You just killed a bunch of plants in the water. And you know who else is going to die, Sarah?
Me.
No. What eats the plants in the water?
The fish.
Sure, the fish and insects and other aquatic wildlife. So it's important we protect the wildlife. When we protect water, we definitely help protect aquatic wildlife. Humans, what impacts do pesticides have on us? The jury's still out. A lot of people have talked about Roundup and possibly causing cancer. Others, who knows? DDT. We talked about DDT from the past, didn't we? We talked a little bit about it yesterday. DDT. I'm actually going to show a movie or a video on Thursday or Friday on DDT exposure and usage, but it's one of the main persistent pesticides that was used to kill insects back in the 50s and 60s, and it stays around for decades.
What does that stand for?
What?
What does that stand for?
3 gigantic words. I don't know. You don't need to know. DDT. All right. can be complex and expensive. So integrated pest management is not easy. It is time consuming, and stuff costs more than it would in just large monoculture growth. Now, what do people pay more for at the grocery store? A lot. Organic. Why are people willing to pay more for organic? Yeah, I mean, it's you're using less synthetic chemicals. What, Andrea? Yeah, I mean, it takes more work. You're probably gonna have more insects and weed issues, and so you're probably not gonna get quite as high yield. But the benefit, people are willing to pay more if they think it's healthier and better for them. Like I said, my wife, she ate pretty much only organic produce throughout her pregnancies, in the attempt to reduce any kind of chemical exposure to our kids. So I'd say generally the younger you are, especially babies in utero, are going to be more drastically affected than as you get older. And so something to consider. Although a lot of people throughout their lives eat just organic, or they like to grow their own food. So hopefully that's something that we can trend toward. Can you imagine where you could just grow all your own food and go out in the yard and eat it like a rabbit? What?
The other day, we had eggplants, and we cooked them and they were really good.
Oh yeah? I like that you cooked eggplants. I think they look pretty cool, and I think they taste disgusting. But
Yeah, I didn't really like them, but I mean, they weren't like bad.
it tastes like a cheap sponge you would buy at the store. I feel
No,
like
we
maybe
made
it's
it
kind of
like-
dense.
We made them like chips with like cheese, so it was kind of like eating
Oh,
potato
you just covered them
chips.
with cheese then.
It was kind of like eating potato chips, but it was still just not great. They weren't bad. It just,
Well, they are cool looking. I've only had one experience with eggplants, but whatever floats your boat. Am I right, people? Grow some of your own food. Know where your food comes from. Peace.